Everyone, section 3.5, equations of parallel and perpendicular lines. So example 1 is kind of tricky, not going to lie. It's a little harder than it might look originally. So the first thing we need to do, so if C and D have these coordinates, find the coordinates of point F along the directed line segment CD so that the ratio of CF to FD is 3 to 5. And you would think that we're going to use a 3/5 ratio, but we're actually not. We're going to use a 3/8 ratio, and I'm going to hopefully be able to explain that in a minute. Let's start off by finding the slope of segment CD. When we do that, so we got to do rise over run. So -3 minus 5 is -8 over run. 8 minus -4 becomes 12. And here's the key: you cannot reduce this. Okay, normally when we have a fraction like this, you would reduce it, but we do not want to do that in these types of problems. We want to leave -8/12 as what we're going to be using. So why is it that we're going to use a 3 to 8 ratio and not a 3 to 5 ratio? So if we, and I'm not going to actually plot these, but if this is point C and if this is point D, we want to break these up into a 3 segments, 1, 2, 3 segments, 1, 2, 3, 4, 5 segments. So we want to break this up into a 3 to 5 ratio. Well, that's really a 3 out of 8 segments. So there are 3 segments here, there are 8 segments total. So that's why we're going to break this up into a 3 to 8 ratio. We're going to use a 3 to 8 ratio to solve this. So what we do is we're going to take the rise part here, the -8, and we multiply that by the 3/8 ratio. When we do that, we get -3. Then we're going to take the run part here, the 12, and we're going to multiply that by the 3/8 ratio. And when we do that, we get 9/2 or 4.5. And we're going to take each of these parts and we're going to add that to point C. Okay, so we're going to add -3 to the rise part of -3 or of C, or the Y part. So the Y part is 5. We add a -3. It's really 5 minus 3. And to the X part, we're going to add a 4.5. So -4 plus 4.5. So our final answer is 0.5, 2. And that's the answer to example 1. So example 2, on the back side here, complete with always, sometimes, or never. So the slope of a line joining 0, 3 to 2, 1, well, we have to find out what that slope is. That's going to be -2 over +2 is -1. So always -1. It's because the slope between these 2 points is -1, so the slope between any 2 points on that same line is -1. If 2 lines have equal slopes, then they are always, sometimes, or never the same line. Sometimes. Sometimes they're the same line. Most often they're parallel. Okay. The slope of a line is always, sometimes, or never a rational number. Sometimes. Sometimes it's an irrational number. Could be √2 over 2. D, the slope of a vertical line is 0. So vertical, straight up and down, and the slope of the vertical line is not 0. Slope of a horizontal line is 0. Slope of a vertical line is undefined. So never. And the slope of a vertical line is, slope of a horizontal line is always 0. Okay, the slope of a given line is always, sometimes, or never the same, even if different points on the line are chosen. It doesn't matter which 2 points you choose on the line, you're always going to have the same slope, so always. The definition of slope, always, sometimes, or never, includes vertical lines. Never, because vertical line's slope is undefined. So how can it include that definition? Never. Okay. Lines A and B are perpendicular. Lines A and C are parallel. So the slopes of A and B are going to be negative reciprocals of each other, and the slopes of A and C are going to be the same. So the slopes of A and C are going to be the same. Negative 1/3, 21. G, 2f over 3. Slopes of A and B are going to be negative reciprocals of each other. So 3, negative 121, negative 4, positive 2/7, negative 1 over G, and negative 3 over 2f. And the only ones left are here and here, and these are going to be the same, so negative 4 and 2/7. Pretty easy and quick to fill those in. Example 4. Are two lines with given slopes parallel, perpendicular, or neither? This reduces down to 3/4, so these are parallel. These are negative reciprocals of each other, perpendicular. These are not negative reciprocals of each other. This is the only unique time where it doesn't look like they're reciprocals. These are not reciprocals. They are negative to each other, but they're not reciprocals. So this is neither. These are reciprocals, but they're not negative to each other. They're both negative. One's got to be positive, one has to be negative. So this is neither again. These are reciprocals, and one's positive, one's negative. Perpendicular. Just because the negative moved from the top to the bottom does not make these reciprocals, and it doesn't make them negative to each other. These are actually the same. Therefore, they're parallel. This is a slope of 0. The perpendicular to a slope of 0 is undefined, not negative 1. Neither. And like I just said, slope of 0 and undefined, they're perpendicular to each other. Okay. If AB is parallel to CD, find the value of T. So whatever the slope of AB is, the slope of CD is going to be exactly the same. So let's find the slope of AB. Slope of line AB equals 9 minus 5 is 4. Negative 3 minus a negative 1 is negative 2. So negative 2 is our slope. So the slope of CD is negative 2. Slope of segment CD equals negative 2, which is equal to T minus a negative 9, which is T plus 9, over 0 minus 4. So negative 2 equals t plus 9 over negative 4. Multiply both sides by negative 4. 8 equals t plus 9. Subtract 9. T equals negative 1. Okay. Example 6. State the slope of the line and a point on the line. So luckily, part A and B and C are all in point slope form. So stating the slope, m is equal to 4/5. And we have the point 3, 4. Slope here is negative 1. M equals negative 1. And we have the point negative 4, 0. Here we have a slope of 2. And we have a slope point negative 5, negative 3. Okay, so here we have a slope of 1. That's easy. And what's being added or subtracted to the x? Nothing. What's being added or subtracted to the y? Nothing. 0, 0. The origin is a point on that line. Here we have a slope of m. M equals m. And we have the point k, p. K, p. That's example 6. Example 7, find an equation of line containing 9, 3 and having a slope of negative 2/5. Y minus 3 equals negative 2/5 x minus 9. Am I ready to move on to the next problem? Example 8. Find an equation of a line containing points 2, 4 and negative 3, 1. So let's find the slope and then use either one of these 2 points. It really doesn't matter. So our slope, m equals 1 minus 4 is negative 3. Negative 3 minus 2 is negative 5. So we have the slope of 3/5. So y, let's on the answer key I used this one. I'm going to use this one now, not that it matters. Y minus 1 equals 3/5 x plus 3. That's an example, answer to example 8. In example 9, find the point of intersection of these two lines. So what we need to do is we need to set them equal to each other or solve this system. If we can set them equal to each other, that's great. Or we can use combination. I'm going to use I'm not going to use combination because you might not remember that one from Algebra 1, but you definitely remember substitution. So x equals y plus 2 when I solve this equation here for x. Now I can plug this into my x here, and I get y plus 2 plus y equals 12. 2y equals 10, y equals 5. If y equals 5, x equals 7, and we get the point 7, 5, not 5, 7. 7, 5. 7, 5. There's part A. Part B, I'm going to solve this equation here for x. X plus y equals 5 if I divide everything by 2. X equals 5 minus y. Substitute that in place of x here. 5 times 5 minus y plus 3y equals 21. 25 minus 5y plus 3y equals 21. Let's see, that's negative 2y. Bring that over, that's negative 4. So negative 2y equals negative 4. Y equals 2. If y equals 2, then x is equal to 3. And I get the point 3, 2 as my answer to example 9b. Example 10, write an equation of a line through point P parallel to line OM, where O is the origin and M is 5, -2. So what I'm telling you here by telling you that O is the origin, M is 5, -2 is the slope of line OM. Once we know the slope of line OM, we'll know the slope of the line that goes through this point parallel to OM. So let's find the slope of OM. Origin slope is going to be -2 over 5. -2 minus 0 over 5 minus 0. So that's my slope. It's got to go through this point. So now we have y minus 1 equals -2/5 x minus 4. And there's the example 10. Example 11. Write an equation through the same point, perpendicular this time to line OM. So the slope of line OM is still 2/5. The slope of the line perpendicular to that is 5/2. Y minus 1 equals 5 over 2 times x minus 4. And there is example 11. Example 12 is the longest problem in this section. Example 1 and example 12 are probably equally difficult, but example 12 takes longer to do. Okay, so we're going to find the distance from a point to a line, and that's something that you defined in section 3.4 as the different distance from a point to a line is perpendicular distance from this point to this line. So what does that mean? It means I got to find the slope that is perpendicular to this slope, to this line, and then it goes through this point. Once I've done that, I've found that equation of the line that is perpendicular to this one and goes through this point, very similar to what we just did here. Then we've got to find the intersection between that line and this line, what we did here in example 9, and then we'll use the distance formula between that intersection point and this point. So it is a bunch of steps. I'm going to flip over to the back side so that I have plenty of room to do this. So let me just recopy the given information. We have 0.6, -2, and we have the original line y equals 2x minus 4. Okay, so let's start off by finding the line that is perpendicular to this, going through this point. So the slope of that new line is going to be -1/2. And so we'll call this step 1. So step 1 is to come up with the equation of the line with this slope going through this point. Y plus 2 equals -1/2 x minus 6. Now I have to find the intersection between this line and this line. So step 2. So to do that, like we did in the earlier example, we're going to take this, which is solved for y already, substitute it in place of y here. Now I have 2x minus 4 plus 2 equals -1/2 x minus 6. 2x minus 2 equals -1/2 x minus 6. Let's get rid of the -1/2. I'm going to multiply everything by -2. -4x plus 4 equals x minus 6. Let's bring this x over, bring the 4 over, so I now have -5x equals -10. X equals 2. If x equals 2, then y equals 2 times 2 minus 4. So y equals 0, and we have the point 2, 0 as our intersection point. So step 3, our final step, is to use the distance formula between these 2 points. D equals square root x2 minus x1 squared plus y2 minus y1 squared, all inside of the square root. Square root of, let's do 6 minus 2. 6 minus 2 squared plus negative 2 minus 0. Negative 2 minus 0 squared. This is 4 squared, or 16. Square root of 16 plus negative 2 squared, or 4, which is square root of 20, which in simplest radical forms 2 square root 5, which you should remember from last year, or about 4.5 units if you use a calculator to do square root of 20. And there's our final answer. And that's all of section 3.5. Thank you very much.